Here is the first question. You check. I will solve it, but I want to know procedure. How will you guys solve? Okay. Hmm. Okay. Yeah. So, can you tell me what will be the answer? Yeah. Hmm. Option D is the right option here. Abhishek and Jitendra, you can also try for this one. I will solve after 2 to 3 minutes. First, you try. Here, gamma iron it transforms into alpha iron. So we already know this is FCC structure, crystal structure, and this is BCC, and this is 72% closed pack you will get, and here it is nearly 68 if I am not wrong. So if you see here, this is for FCC I am trying. This is more closed packed plane compared to this BCC, so it will be expand, volume expansion we will get. So can you tell me the relation in FCC A and R? If R is atomic radius and A is this lattice parameter for FCC, I am asking. Abhishek, okay, means 4R equal to A root 2. Okay, so A FCC lattice parameter will be equal to 4R by root 2. And for BCC, what will be? This length. So A root 3 will be equal to 4R. So for A BCC, it will be 4R by root 3. So this AFCC, this is for in FC total number effective number of atoms will be 4, and for BCC it will be 2 only, because at corner there are 8 1 by 8 plus at body center cubic, so it will be 2, and for 4 it will be 6 faces, centered face 1 by 2 plus 8 into 1 by 8, so 3 plus 1 equal to 4. So this is for, and if we want to calculate volume of FCC, it will be AQ FCC, and here volume of BCC, it will be AQ BCC. This volume is for 4 atoms. So if we want to calculate for per atom volume per atom, it will be suppose V dash AQ FCC by 4, and in this case it will be 2, and it is asking volume expansion. So it is from FCC to BCC. So volume expansion will be equal to V dash BCC minus V dash FCC by initial value. So can you calculate now? Can you tell me value? Because R here we are taking for iron, this is radius of iron, so it is same in both cases. Is there any issue? You can ask. RQ will be cancelled out. What will be this value? Anyone? Eight point eight. Okay. You will get 0.08866. This is volume expansion, and it is asking percentage volume expansion. So just multiply by 100, you will get 8.866%, which will be nearly 8.8%. This is our option. Option D is the correct option. Can anyone is having any issue? You can ask. Is it okay? Kamesh and Jitendra. Okay. Then we are moving to next question. You read this and tell me how will we solve. It is related to electrochemical potential. You know Nernst equation? You just put all value, you will get. Try to solve. This is some product. This is reactant. Reactant concentration equals. This is standard electrode potential. This is Faraday constant, and number of electron involved, room temperature. If we are considering temperature in Kelvin, and our gas constant. For this, you write equation reaction. Sorry, reaction. If you write, you can solve. And also we know for aqueous solution at 25 degrees centigrade, pH plus pOH value it is 14. Because here P partial pressure of hydrogen and oxygen are given. So can you tell me reaction? Oxygen reduction reaction. This is 4OH minus. Here it is given O2 to 4OH minus. Yes. Yeah, we can write. This is for oxygen reduction reaction. Hydrogen evolution. Can you write? Can you tell me? Hydrogen evolution. It is, see here it is given 2H plus 2H2 standard. This is standard electrode potential. So here we'll write 2H plus 2 electron H2. So value of this is given, and this value is also given. E naught value for first case it is 0.4 volt, and in second case suppose it is 0 volt. So what will we do? H2 we can write this one 2H2 4H plus 4 electron. I want to combine these two reaction, and for that here it is 4 electron, here it is 2 electron. So I have multiplied by 2 and just reverse it. So here you will get E naught 3. If we are assuming it will be same 0 volt. So E naught 1 plus E naught 3 will be 0.4. Suppose this is E naught 4. So just you add this one and this one, you will get O2 plus 2H2O, and this 4 electron will be cancelled out. Here it is 4 electron plus 2H2. what I am doing, I am cancelling electron from both sides. OH minus plus 4H plus. Is it okay? For this, our E naught value is 0.4 volt. Is it okay? Is there any issue? You can ask. Till now. So can you now solve? Already we know this equation, Nash equation. Can you put value? This is our product, and we know pH plus POH 14 for aqueous solution. Zero 0.4 to 98. This is in Kelvin into R value 8.314. In number of electron involves, we can write 4. Faraday constant 96500. So this value is 1 PO2 and pH2. This is 1. This is water, so we can assume 1. 0.4 minus 298. Can you tell me what will be the OH minus into H plus? We know minus log H plus. OH. So we can write this term, this one, 10 to the power minus 14. Is it okay? OH minus into H plus. Is it okay for you? Minus 1 into ln 10. Can you solve this one? And if there is any issue, you can ask. Hello? Okay. Yeah, it will become nearly 1.23 volt. It is right, 1.227. Are you getting this one? This one, because I have written directly 10 to the power minus 14. So from here you can solve, you can get this one. Because pH value means it is minus log H plus hydrogen concentration, and pOH value means minus negative log of OH minus concentration, and it will be equal to 14. So if you will solve, you will get this much value. And if you put here 10 to the power minus 14, and already there is 4 power, so it will be minus 1. I have multiplied because this is minus 14. Is it okay? This is our correct option. So should we move to next question? Hello. This is related to convection and radiation problem. Can you tell me the process after reading this question? How will you solve? Yes. Hmm. Hmm. Yes. And in both cases, mass flux we will equal in both cases mass flux Q by A value. Hmm. So if you will equalize both equation, you will get value of T, the actual gas temperature. Emissivity is given 0.5. So for convection problem, Q by A value will be equal to H T1 minus T2, where H is convective heat transfer coefficient, and for radiation problem it will be Q by A will be equal to emissivity into Stephen coefficient into T1 to the power of 4 minus T2 to the power of 4. So for convection, H value is given 100 watt per meter square per Kelvin, and temperature we have to find temperature T, gas temperature, and thermocouple temperature it is given 800. So T minus 800, and in this case emissivity is given 0.5, and Stephen coefficient it is 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. And here emissivity here we are calculating from 800 to 500. So this is our actual gas temperature. What will be the value? Can you tell me? 898. Yes. Which will be nearly 900 Kelvin. So it was related to convection and radiation. There is one more question related to this. You can try for this. This is related to conduction. Oh. Conduction means we know Q by A, heat flux will be equal to K dt by dx. And here suppose 0 to t. You first try for this one. I will write this. Thermal conductivity is given and here it is 2 K value. This is maximum 1300 Kelvin and the cold phase of the outer layer is 400. Here suppose it is 400 Kelvin. You have to tell temperature at the interface. The temperature at the interface between the two layers. Suppose this is temperature profile. Yes, it will be 850. Suppose this is T. B equal to K into 1300 minus T. Q by A will be equal to K into. So what will we do? We know this equation. So first of all, we'll calculate for this one from 1300 to T. So we have got this one, and again what will we do? We'll integrate from T to 400. So we will get this one, and we will equalize both. Already we know B1 value, this is 450, and B2 value 900. So 1300 minus T, K value 2 by 1, and T1 minus 400. This is 2, cancel out, to T1 equal to T1 equal to 850 Kelvin. Now you can ask, is there any issue in this question? Hmm. Okay, then there will be a H value will be given in that condition if there is some convection. And if you are saying like if there is air, means radiation will be there. Like in earlier cases we have solved this question, right? So in that case we will try it that way. Suppose fluids are given, then we will apply for convection equation. And if there is a gap like radiation, through radiation if heat is flowing, then we will apply this equation, this one. There is one equation, one question it was asked in GATE 2014 or 15. You can try for that. Is it okay for this question? Jitendra? You can ask here. Just I have integrated this from suppose 1300 to T, and again T to 400, and already this dx is given. For dx, suppose I can write dA into dx dt by dt. K is constant from 1300 to T, and here from 0 to 450. This is in mm. X, if we are assuming this is constant q by a, so q by a 450 equal to k T minus 1300 divided by this value, and here it is coming 1300 minus T. That means I have integrated from T to 1300. So later on you will get same answer. Is it okay? Jitendra, Kamesh, Abhishek. So we are moving to next question. If there is any issue, you can ask Kamesh and Abhishek. Okay. Okay, first you solve this one. After that, this one. This is Arami equation. You know Arami exponent equation. E to the power minus n. Sorry, plus n. This is fraction, solidified fraction, and k is rate constant, and t time of transformation. and n is at time exponent. It is asking to calculate this our army exponent n, this value. Everything is given, like 20% means 0.2 will write fraction. Are you solving? Hello. See, 20% complete. That means 0.20. We can write directly 1 minus exponential minus k. It is not given. K value is not given. 45 seconds. It is taking 45 seconds. And we have to calculate this n value. Suppose this is equation 1 and 85% minus k into it is taking 75 seconds. Equation 2. So from equation 1 we can write exponential minus k 45 to the power n 0.8. I have subtracted this 1 minus 0.2. This is suppose 3. And if we take ln both sides, we can write directly 45 to the power n. After taking ln, you will get natural log. You will get minus 0.22314. Similarly, you can do for this one. It will be minus k 75 and natural log of this value. This value means 0.15. It will be minus 1.8971. Just subtract both. You will k will be cancelled out. And can you tell me now n value? Yes, 4.1. So 45 by 75 to the power n 0.1176. Again, if we take natural log n ln 45 by 75, and this value will be minus 2.14029. So n value will be 4.189. Is it okay? You just take care of this both side natural log. If you are taking, and if you are missing one side, then there you will not get right answer. So we are moving to next question. You can try for this. It is related to semiconductor. Silicon is doped with arsenic. Concentration is given 10 to the power 20 atoms per meter cube at room temperature. The electron and hole mobilities are in silicon are given. The conductivity we have to find out at room temperature for silicon doped with arsenic. So can you tell me how will we solve? We know silicon, it is 4 valence. Yes, yes. Hmm. Yes. Here this is conductivity. This is a number of electrons. This is number of holes, and this is 3.04. No, no, it will. Okay, wait. And this is electron concentration. This is mobility, electron mobility. This is hole mobility. So can you tell me which type of semiconductor it is when silicon is doped with arsenic? Hmm. So silicon it is 4 valence, and arsenic it is 5 valence in outer shell. So this will combine. This electron will be extra electron. This is electron means minus electron. That's why it is called N-type semiconductor. And for P-type, suppose this is phosphorus, then it will be P-type. In phosphorus case, this is silicon, this is silicon, silicon. In outer shell, not phosphorus. It will be for phosphorus. It will be 5 again. Suppose for indium, IN. In outer shell, there will be 3 electron, and for silicon, it is 4. So it will combine this one, and there will be no electron for indium to for this silicon. So this will combine, but this will be whole. This is extra one. That's why we call it P-type semiconductor. So here mu is given. Mu e is electron mobility 0.14 meter square per volt per second, and mu h it is given 0.05 meter square per volt second. How did you get 3.04, Kamesh? How did you get value 3.04? Okay, concentration is okay. Hmm. So concentration of electron is given. Concentration of hole, where it is given? Are you getting? Okay. Concentration of hole is not given here, so we will assume 0 because this is silicon is doped with arsenic, so there is no hole present. This is only electron, extra electron. Are you getting? So that's why I have explained here. So sigma will be equal to mu ne. Ne value is given 10 to the power 20, and electron we know, for electron it is 1.6 into 10 to the power minus 14. This is coulomb. 0.14. So if you will solve, you will get 2.24. No, but this is n-type semiconductor. There is no hole present here. Silicon is doped with arsenic. Yes. So here see 10 to the power 20. So let me balance this atom per meter cube, and this is coulomb. Coulomb is Q into IT. We can write ampere into second, and this is mobility. It is given meter square volt per volt second. So it will be cancelled out. We can write ampere by meter volt, and 1 by meter, volt by ampere. Volt by ampere we can write ohm, 1 by meter ohm. That's why we are getting this ohm meter inverse. Are you getting this one? You also balance this dimension also. Take care of dimension. Is it okay? Any issues in this question you can ask. And if it is asking, it is saying in question it is intrinsic type, then you have to assume both hole concentration is equal to this electron concentration. There is one more question you can try for this. It was asked in GATE 2019, I think. Is there any issue in this question? Okay, you can try for this one also. Both are same, but here it is given intrinsic silicon. Intrinsic means both are nearly same. Hole concentration and electron concentration. It was asked in 2018, I think. What will be the answer? Can you tell me? Just you put all values are given. 4.8 what? Yes. And dimension. Already I have written it. Yes, comments it will be the right. So for intrinsic, we can assume both are same, hole concentration and this electron concentration. So sigma conductivity will be equal to Ne into E mu E plus NH E into mu H. This is same. This is also we know. So we can write 1 into 10 to the power minus 16 into 1.6 into 10 to the power minus 19, and mu e plus mu h 0.1 plus 0.2. So if we solve, we get 4.8 into 10 to the power minus 44 ohm meter inverse. Is there any issue? If it is p type, then just you ignore this. In p type, suppose concentration is given any, just ignore this one, just calculate this one. If it is intrinsic, take both, and if it is p type, then you take this one. Is it okay? Should we move to next question? Sanjeev, is it okay? Per unit in ethylene, atomic weight are given. Calculate number average degree of polymerization. Can you tell me atomic mass of ethylene? Number of molecules are given. Molecular weight corresponding to number of molecules are also given. And atomic weight of carbon and hydrogen are given. So C2H4 28, yes. If it is methane, then it will be methane is CH4, and if it is acetylene or ethylene, then it will be C2H2 26. You know this CnH2n plus 1 to CnH2n CnH2n minus 2. This is for alkane group. This is alkene. This is for alkyne. So this one, degree of polymerization. Now can you tell me? Suppose n number of degree of polymerization, and we know atomic mass. This is 28, and corresponding it is given 2800 into 10 plus 3000 into 5 plus, will do for all 1 divided by total number of molecules 10 plus 5 plus 4 plus 2 plus 1. So if you will solve, you will get n value nearly 90, 90.9. Is it okay for you? You can check Callister. I have taken from there. This was asked in GATE 2010, I think. Hello. And based on this, there is one more question. You can note down. I am writing here equation only. You will solve it. Mass average molecular weight mw, if we denote it by mw, then it will be sigma mi into ni by sigma ni, and this is mass average. If it is number average molecular weight, then we will write sigma mi square ni divided by sigma mi ni. And this one polydispersity index means, if we denote it pdi, it will be equal to mn by mw. And here it is given range. So if we want to calculate mi value for this fraction, it will be 5000 plus 25,000. We will take mean value. So 30,000 by 2 means it will be 15,000. So you try to solve this one: weight average molecular weight and polydispersity index. Weight average molecular weight you will get after calculation 9.9 into 10 to the power 4, and PDI value you will get 2.1. You just put the value. You please visit Calista, it is given. It was asked in GATE 2009, I think. So you can ask if there is any issue in previous questions. Have you noted this one? Hello. Okay. So is there any question you can ask? We will close this session. Yes. Irradiation, conduction, convection, radiation, you will get NPTEL. You just search NPTEL, any professor from IIT Madras, IIT Delhi, or IIT Kharagpur, you will get. There are many videos related to this. So is there any issue in previous questions? I will solve later on this one. You can ask. Hello.